My name is Alex Dworjan. I'm an Ansible specialist, and I'm going to be walking through how you can leverage Ansible with AIOps. So before I can jump into how Ansible helps in this process, I do want to discuss what AIOps is. So it's specifically infusing some sort of AI tooling into your existing IT processes. Generally, I see this as reviewing incidents or problems or whatever ticketing system that you leverage to either deduplicate tickets, group them together, provide root cause analysis, just do some sort of additional analysis on logs or events that are coming in and possibly, again, providing root cause analysis or going the other way and even getting to the predictive state so I can see that an issue may arise before it ever comes up and I can take those actions to prevent outages. So how does Ansible tie into all of this? So I can leverage Ansible to help with some of that root cause analysis. So maybe I don't already have a tool that's providing all of these logs into a ticketing system, into a log aggregator. What I can do is I can have Ansible on an alert from something like Datadog, Dynatrace, or really any sort of monitoring solution to gather the logs from that troubled service, push it to that AI to do that root cause analysis, and then I can even go through the process of automating that remediation. So I can tie into another AI like Ansible Lightspeed to do that generation, and then throughout this process, provide updates. So take that root cause analysis and put it into my ticketing system like ServiceNow, update it when things are completed, so I can really have an end-to-end process tying into AI for the root cause analysis, deduplication, as well as AI to do that playbook generation. So let's look at a simple diagram of how I've got this put together. So I leverage to do that initial installation of all the end agents, Datadog, Dynatrace, Prometheus, and Alert Manager, whatever monitoring solution that you want to use. When they detect an issue, in my case, I'm going to do an Apache web server issue. That's going to trigger a webhook into my event-driven Ansible server. And then that will also cause my larger workflow, which will then go through the process of gathering the logs on the affected virtual machine, sending that to my AI tool, in my case, RHEL AI, to do that root cause analysis. I'll then take that root cause analysis and send it to Lightspeed in order to do that full playbook generation. And then I'm going to take that playbook and use that to run my remediation across the host that's affected. All of this will be provided out, in my case, to Mattermost from the chat perspective and ServiceNow from a ticketing perspective, so everything is logged and available to use. So you want to see this in more of a nice flow. This is essentially the idea of I'm detecting some sort of error, in this case on an Apache web service. I want to take that from event-driven Ansible, picking the event from whatever the source is, sending those logs to that AI source, taking that process and sending that root cause analysis to ServiceNow for logging, send that information then to Ansible Lightspeed to get a full playbook, and then running the remediation. So I really can have any tool generating that initial event. I can leverage any AI that you want as well. This isn't limited to RHEL AI or OpenShift AI. And the other beautiful part is this takes a more complicated use case. So it's not just, hey, the web service is down, let's restart it. I need to know why the web service is down so I can make changes before I go through that restart process. And that's what I'm going to show here in a second. So let's jump into a demonstration so we can see exactly how this works in an environment. So I'm going to start off the demonstration by, in my case, breaking the Apache web service. But as you can see, my web service is actually up and running. I don't have any errors from my Datadog application, so I can see that everything is healthy. So I'm going to go through that process of breaking the Apache web service. I'm specifically doing it on one host, but all I'm doing is adding an invalid line into the Apache configuration and then trying to restart the service, which will cause it to fail. So while the playbook itself will appear as successful, the restart itself, the application will fail because that is an invalid line. So I can very quickly restart this page and you'll see that it's not up and running. So while I am using Datadog, you can use any monitoring tool, Dynatrace, Datadog, Prometheus, Alert Manager, really whatever that you have monitoring that service. So I'm using event-driven Ansible specifically tied into Datadog. So I've gone through other videos to show how you can set up Datadog to talk to event-driven Ansible. But in this case, I'm looking for a specific event title, triggered web server is down, which is what I'm monitoring here. And that then will call a specific workflow that I've set up for that AI response. I'm passing in that VM name, so I'm only running this on one VM because I know that my web server specifically is Apache. I am passing that as a service issue. I've set up all of this to be as platform agnostic as possible and as service agnostic as possible so that it can work for Nginx, Apache, really all kinds of different variants depending on what you're looking for. So if I go back to Datadog, I'll actually see that the event has triggered. I can actually go into the web service and go into Ansible and kind of see what I'm running through. So this is my AI response job. So that first job is going through checking the status. Let's make sure that the web service is down, and let's gather logs for that particular service. I pass those logs to my next playbook, which is doing essentially an AI send. It's also creating a ServiceNow ticket and providing information to Mattermost so I can see that root cause analysis. I also take that root cause analysis and pass it in my next playbook to Ansible Lightspeed to do playbook generation. So if you're not comfortable with automatic playbook generation, automatic remediation, I can either stop before this step or stop after the remediation. You can add in an approval step here if you want to make sure, hey, this playbook is doing what I want before I do that automated remediation. I'm going to kind of go into the extreme to show how I can really do an end-to-end solution with AI in this case. I did still add in, if for some reason that automatic remediation fails, update my ServiceNow ticket, update Mattermost, say a manual intervention is required, or if it's successful, close all that out. So in theory, by the time I walk through this entire process, this is actually up and running, and it is. I can see in my chat the root cause analysis. So you can see that these are those exact logs that got shipped over. So I can see that my timestamp is 2:51 p.m. This is 2:49, so it does line up perfectly. I'm not doing any hand waving behind the scenes. And I can see that it's specific. He calls out the root cause of the issue is the Apache configuration file. There's a specific line. I've tried to get detailed and have it find the exact line that the issue is, but I try to make sure that if I use something more consistent rather than just removing the line, I'm actually going to use this to say, let's replace this entire configuration file from my known good. I do create a ServiceNow ticket, and because it's already been closed out, I also close out that ticket. So I can see in ServiceNow, I've created the ticket, I've put in that root cause analysis that you saw in my chat. So I can see the root cause is that Apache configuration file, specifically that VM name, and I close out the ticket that the remediation has been completed and closed. So I can already see that it's in a closed status. So let's jump into the playbooks themselves. So that check status, again, I tried to make this as agnostic as possible so this could work across multiple services. So I'm basically just verifying if the service itself is running. If it is, obviously don't do anything else. If it's not, then grab the last 20 logs of the service logs. This is all set up for RHEL, which is why this is using journal CTL. But you could modify this based on what sort of logging service is leveraged by that particular platform. I am storing them as a variable and also sending them. So this helps to generate my prompt for my AI. In my case, I'm using RHEL AI, but this really could be ChatGPT, any sort of model that you have available to you. The beauty of using something like RHEL AI or OpenShift AI is all of this can live on-prem. So I'm not sending this to any sort of publicly hosted AI solution, and I didn't need to train the model, so I'm just using a normal Granite model, and it's able to handle this particular log and still give me that root cause analysis. But as you can see, I basically just hard-coded in like the summary of the root cause of an issue on a RHEL server with the specific service issue, so HTTPD that I passed, and I'm passing in those 20 logs. So it's using that to generate that prompt. And I'm also setting the max tokens in this case to be 2,000. If you're not familiar with AI, you need a certain number of tokens based on how large the prompt is and how much processing you want. So I'm hard coding in. Let's use up to 2,000 tokens. For the AI communication, I'm just using the API for my particular AI. I'm passing in that prompt that I had before with those tokens, and it gives me back the response of here's what that root cause is. The one particular piece that I added in was because of that lack of consistency from the AI. If I get that the service config, so http.conf in this case, is somewhere in the response, I want to pull from my known good, push it to that service configuration location, and restart the service. So I've made this, again, as generic as possible. In my repository, which I'll show in a second, I do have an http conf in there, so I'm pulling from my known good if that is an issue. I then notify Mattermost with that information, so that's that exact prompt with the response in there. I create that incident in ServiceNow, and then I pass the number along as well as that incident. So again, Mattermost can provide that information to the end user if you're not already logged into ServiceNow. from the Ansible Lightspeed side of things. So I'm using this to do that automatic playbook generation. So again, I'm hitting the API for Ansible Lightspeed, providing my token, and providing that prompt that I showed before with specifically on this host. I specifically passed on host because I wanted to create a playbook with that host's field filled in. So I know it's only going to respond to that host with this particular issue. I show the prompt, and because I want this all to end up in version control, I actually sync this with my Git repository and push it there. So I sync down the existing repository, push that final file, and push it back. So if I go into my repository, I call it lightspeed response.yaml. So I can go in here, lightspeed response.yaml. If I resync this because it's not 3 days old anymore, you'll see that it's now 5 minutes old, and I can see that it specifically has that host, copies in my known good to the Apache configuration location. Lightspeed was smart enough to know what that configuration location is, and it restarts the service. So if I go into Ansible, I can actually find the workflow that ran, and I can see that that entire automated response took under a minute. So pretty quick in terms of getting the alert from Datadog, going through the process of gathering the logs, pushing to AI, pushing it to Lightspeed, and doing the resolution. So I can see each of those individual steps. So if you want to see, the actual send to AI portion, I can see exactly what that response is. So you can see that I'm sending, here's that root cause that I get. If I go back to the workflow and I go into Lightspeed generation, again, I can see here's what that playbook output is, which I end up pushing to my Git repository. And then I can see the resolution of the Lightspeed remediation. So I can see that it did copy the known good configuration, restart of the service, and I'm now back up and running. So you can be as detailed as you want in terms of making this for one specific use case, one specific file, or you can try to make it as agnostic as possible for many, many different services. So the same thing could apply to Nginx, could apply to a database, anything that I can monitor a service for and pull, journal CTL logs from, I've got that capability. So really trying to make this as reusable for AI helps make this process as easy to use across multiple use cases. Hopefully that gives you a good idea of how you can use Ansible and AIOps as part of a larger workflow for really any sort of event-driven operation. I'm going to paste in the chat below content around RHEL AI and OpenShift AI. However, you can really use any AI technology that you have available to you. As you saw in the playbooks, I was just hitting those APIs. So any AI model that has an API available to it, I can leverage to do that root cause analysis or do that generation. I'm also going to include my repository down below. If you want to expand it out to add in other Linux variants, other Windows variants to do that log aggregation and log gathering, please do so. I always enjoy the fact that the community can help grow these particular pieces. Or if you've got better chat prompts, please include that as well. Always looking to grow on that side of things. But they should give you a pretty good starting point of something that you can do just to get started with AIOps and some Ansible, just leveraging probably some of the existing things that you have in your environment. So thank you for taking the time to learn a little bit more about how Ansible can work with AIOps. Hopefully this gives you a good starting point as you look into that journey. Click my picture on the right to subscribe, or click the image on the left to watch another video.